In this demonstration, we're going to focus on working with tables and databases, that is, creating one-to-one and one-to-many relationships between different data tables that may hold some non-spatial data that we want associated with particular features. Now, we're also going to work a little bit with calculating fields and creating new data based on either the geographic characteristics of our features or something else that we might want to calculate it based on. So the first thing you should probably want to check is that you have your data downloaded. In the Demo 7 folder that you should have extracted, you should have an example set of the soils for Notre Dame that were digitized using the process in the preceding demo. You should have a few different database files that yours may or may not say that they're openable in some other program the way mine do. You should have one for water measurements, one for water sites, and then one for the soil descriptions for St. Joseph County. So once you're in ArcMap, as usual, go ahead and load up a blank map. And we want to add in first our soil data and the soil descriptions for that particular data layer. Now, I'm not going to go through the process of adding these things again. If you don't already have your folder connected, I encourage you to look at one of the earlier demos that'll show you how to do that. So we want to just add the two that are for the region of northern Indiana where Notre Dame is, the soils for Notre Dame here, and then the soil descriptions for St. Joseph County. So just go ahead and select those two and add them. So what you should see right off is that we have a fully digitized soil map right here. And if we open the attribute table for it, we have the soil codes filled in properly, but that's really the only information that's in there. And while I might be able to guess that a W is water, I really don't have any information intuitively about what UEWA is as far as the soil code is. So if you go ahead and open up the other layer that you have here, the soil descriptions, what you have is for each soil code, you have a description of it, the formal name, whether or not it's good farmland, and that's it. That's all we have added in here. There's lots and lots of other data that are in the soils database that I didn't include, and that's just because they could be kind of complicated to have them. So what we want to do here is we want to append for each soil code in our soils shapefile all of the information for that soil code from this descriptions file. And this is really easy using a one-to-one relationship or creating a join between them. So the first thing we want to do is just simply right-click on our soils shapefile and go down to joins and relates, and you're going to choose join. So if you look at remove join, there's nothing on there yet, but eventually that would be how you would remove something. So go ahead and choose join. Now what we want to do is join attributes from a table, so this is correct up here. We want to choose the field in this layer that the join will be based on. Well, it's the soil code, the code that we entered in the preceding demo. It already has guessed that we're looking at the soil description St. Joseph file, and it's already guessed that we want to look at the MUSYM here, which is the sort of symbol, the soil code. This is kind of formally what they call them in the soils database. You could choose another one that wouldn't work, but in a lot of cases you may have to manually choose them. In this case, it's guessed it because they're about the same length and they're both text. So we want to keep all records and just go ahead and hit OK. It's going to tell you something about indexing. It's fine to go ahead and say yes. This is really only important if you have a very, very large file. So it's going to run happily in the background. You probably won't even notice that it's finished. It doesn't give you a pop-up or anything the way some of the other tools do. But now, if I go open the attribute table for my soils Notre Dame, you'll see that for each one of those codes, it's appended all of the information in there, even in cases where it's in there twice. So anytime it found a W, it's given me the description of water there. Anytime it's found a UHPC, it's given me urban land, Hillsdale Tracy Complex 5 to 10% slopes. So you can sort of scroll through. If you have any blank ones, anything where it gave you a null or something is missing, what that usually means is that you had something wrong with the soil code when you entered it. So either you typed it a little bit incorrectly, you have a space before it, anything will really kind of trigger an error there. If that's the case, just go ahead and cancel your join, go back, start editing your shapefile, maybe add in the raster from the preceding demo. See if you can't figure out what that code was supposed to be that you maybe wrote in there incorrectly, typed in there incorrectly. In this case, it's all generated fine. We don't have any nulls or anything. So at the moment, this is a temporary record. At the moment, this is only a temporary join between them. We can make it permanently pretty easily. Simply by creating a copy of this temporary shapefile, it's going to go ahead and bring in those data permanently for us. So if you simply right-click on it and go to Data, Export Data, we have our output in this case is a little bit incorrect, so I'm going to send it to the right spot. We want to put it into our Demo 7 data folder. And this is one where we just simply type the name in here as well. So I'm going to call it Soils Notre Dame with description. And go ahead and hit OK. So it's going to copy everything over. It's going to create an entirely new file for us. And then it's going to ask us if we want to add that in. Now I do want to add it in for now, so go ahead and hit yes. And now when you open up that attribute table, everything is in there permanently. These are going to be with that file forever. Now there's a couple things in here that we don't need as well. It brought in both the soil code and the symbol. We don't need both of these. They're exactly identical data. That's how the join was done. So we could simply right-click up here on the name of MUSYM and choose Delete Field. It's going to make sure that we're correct, that this is what we want to do. We do, so hit yes. And I'm going to do the same thing for this OID. This is a unique identifier that it put into the soil descriptions. It's really not necessary at this point because we have the description and the soil code. Those are the important information for us. So I'm just going to right-click and delete that field as well. So at this point, I no longer need my Soils Notre Dame, my original shapefile, and I no longer need this table that's come in that we used for the join as well. So I'm just going to remove these from my map layer as well. So just hit remove, right-click, remove. Now one thing you may have noticed over here in the table of contents is as soon as we added in something that doesn't have spatial data, it brought us to this kind of file system view as well, where it's telling us the folder that it's in and then the files that are in the map. If we wanted to be able to move things around and put one on top of another, we need to go back to the list by drawing order. This is the one we're used to seeing. Anytime you add a table, it's going to move you back over to this list by source because the table on its own has nothing spatial, so it doesn't have a drawing order associated with it. So the next thing we want to work on is calculating fields and creating new data in the attribute table for this new Soils Notre Dame with description. We have two different ways of doing this in ArcGIS, both of which we have to first add a new field, but then we can do what's called a field calculation, which is creating a new value based on pre-existing values elsewhere in the attribute table. But we can also do calculating geometries, where we use something about the geometry, the geographic feature of that particular feature, to create a new mathematical field. So this could be things like the area, the length of the perimeter, the x-coordinate, the y-coordinate, either of a point or of a center of a polygon. So let's go ahead and first start off doing some of this geography, calculating geography. So if you don't already have your attribute table open, go ahead and open it. And I'm going to go ahead and add a new field. And we do this in Table Options, Add Field. And I'm going to call this field Area. We're going to calculate the area of each individual polygon. Now, these are going to have decimals in them, so we don't want it to be an integer like this, and we certainly don't want it to be text. So I'm going to go down and choose double. This is the largest kind of number that we can have in there with decimal places. We could probably get away with float, but let's just be a little bit more, give ourselves a little bit more room and choose double. I'm going to leave precision and scale at 0. That's just going to default to the maximum. And go ahead and hit OK. So now, you probably notice pretty quickly that we have a new field, but it's auto-populated it all with zeros. That's kind of what we want. So I'm going to go ahead and choose to calculate the geometry of this field. So I'm going to go back to the name, the top of the table of contents here, or top of the attribute table here. And I'm going to right click on area and choose calculate geometry. It's going to tell me that I'm doing this outside of an edit session. It's faster, but it's not going to, there's no way to undo it. That's okay. This is a new field. There's no data in there. It doesn't matter if I mess it up. So I'm going to hit yes. Now it's going to ask me what property I want to calculate. I want to stick with area, but I'm just showing you that you have the ability to do perimeter, or the x-coordinate of the centroid, or the y-coordinate of centroid. These would be different if you had a line shapefile or if you had a point shapefile. If you have two different coordinate systems, you could choose which one you're doing. In this case, they're the same. Now, one thing I'm going to do here is I'm going to change this from square meters to square kilometers. And that's only because numbers get really, really big if you're dealing with square meters. Square kilometers will keep it in kind of a manageable number of numbers within each field. So go ahead and hit OK once you've changed all of this. Area, square kilometers. OK. Again, it's going to say the same thing about the field calculator. So now it's calculated everything for me. So I have my things that are really relatively big, and then I have a lot of smaller ones in there as well. So that's the area of each polygon that's in there. It's not the area of each type of each soil class, but it's the area of each individual polygon. Now this is a useful thing to have, but let's go ahead and experiment a little bit with doing calculating features based on other aspects. And let's classify these areas into kind of small, medium, and large. And this is going to be a multi-tiered, a multi-step calculation based on other attributes. So the first thing we want to do is create the field for these data to sit in. So again, I'm going to go over to Table, Add Field, and I'm going to call this Size Class. Size Class. Now I want this one to be text, so I can say small, medium, and large. So I'm going to go down and choose text, but I only need about 10 characters, so I'm just going to restrict it down to 10. So go ahead and hit OK. Now, the way we're going to do this is we could create a very complicated equation that tells us if it's below a certain area, then we're going to give it this. But what's a little bit easier to do in this case is, if you remember from when we dealt with selections, anytime we have a selection, those are going to be the only features that anything happens on by default. So if I just simply select the smallest ones, then calculate that new field as small, it's only going to do it for those particular ones. Same thing for medium, same thing for large. So that's what we're going to do first, is we're going to go to our select by attributes right here, and we're going to choose area is less than. Now this is a case where we don't want to hit get unique values because they're numeric and they just would give us thousands and thousands of values, or 417 probably different values. But I already know that the areas that I'm interested in here are going to be those that are less than 0.05. So I'm going to do areas are less than 0.05 square kilometers. Now I'm going to hit apply. And you'll see what it's done is it's selected all of those ones that are smaller than 0.05. So now if I go to size class, field calculator, I'm going to choose don't warn me again now because I'm kind of tired of this pop-up showing up. And hit yes. If I now go and just type small and hit OK, make sure you have your double quotes in there or it won't work. It's going to calculate just for the ones that have been selected. So it's not calculating for anything else that hasn't been selected. So now if I go back to my select by attributes, if yours isn't still up, then it's this button right here. In this case, I want to do my area. I'm just going to clear this out. My area, this is kind of my middle one, is greater than 0.05. Now click and And this is a little complicated here. It would be nice if you could just string together the equations here, but this is what's called SQL, or Standard Query Language. And it's a little bit finicky in how it likes to have things. So you want to do area is greater than 0.05, and area is less than 1. So this is going to give us things that are less than 1 square kilometer, but greater than 0.05. So this is our medium class. So go ahead and hit apply. So you can see it's selected a lot of the ones that are in between there, but not every single one. So now if we go to size class, field calculator, and we just change where it was previously small to medium, again, make sure you have your double quotes or it'll fail. It's just going to calculate it for those. So our final class, select by attributes, area is greater than 1 square kilometer. So these are our big ones. So on the screen here we only have one we can see, but you can see down here that 12 out of 417 have been selected. And if you just wanted to see the ones that have been selected, you could choose this part here. So now we could go to field calculator, large, double quotes, hit OK. So now for every feature in here we have a size class. So we have a nice little way of seeing what is a big one, what is a small one, and what is a medium one. So there shouldn't be anything unclassified. It should all be ready to go. So if we hit clear selection, just to make it a little pretty, I'm going to close this down. And then we can go into the symbology here if we double click on our layer. Go to your symbology tab. And if you use size class as your value field and hit add all values, now we can sort of color those differently, and we can see it in a slightly different way. So we can very easily pick out what are the big ones, what are the small ones, and what are the sort of medium ones. So it's a little bit silly to do this calculation of small, medium, large, and we can sort of see that as well. But I put this in here as a way to show you how to do these sorts of multi-tiered selections and calculations using the attribute table in ArcGIS. Now, the next stage here is we're going to work with a point shape file of water quality sampling stations across Indiana. So at this point, we could leave the same data in here. It wouldn't really do us any harm to leave our soils in. But we could also just simply start a new map document. So if you want to save this as sort of Demo 7 Part 1, you're welcome to. But I'm just going to start a new blank map document. And I'm going to go ahead and add in my water measurements and my water sites tables here. So nothing spatial, no shape files, just water sites and water measurements. So add those guys in. And you notice we've gone back to our list by source tab here, and there's nothing showing up because there's nothing spatial yet. These are just two tables. So if we open up water sites, what you see is that we have a location, county, the station ID, the state, the latitude, the longitude, and then these northing and easting are our coordinate system for Indiana. For each one of these water sampling stations from the USGS. Now if we open up the other table here, our water measurements, what you probably notice pretty quickly is that for each site we might have multiple different records. We might have different measurements, different years, all sorts of other things for these individual stations. So there's lots of different measurements all at the same locations. So this is an example of a one-to-many relationship, a situation where we would want to set up a relate between them. So for each site we could see all of the measurements, or for a particular year we could see what sites have been measured. Now the first stage of what we want to do is convert one of these into something spatial. Otherwise it's not really a GIS problem, it's just a database management problem. And this is going to be water sites. This is the one that we want to deal with because it has latitude and longitude coordinates. It's going to be relatively simple for us to project this into a shapefile, into a vector data model. Now we're going to do this by quite simply right-clicking on it and going to display XY data. Now we could do this with latitude and longitude, that's fine to do, but let's go ahead and do it with the easting and northing. And I did misspeak a little bit earlier. It's actually UTM coordinates. They're not. It's not an Indiana coordinate system. So we're going to be able to use the same UTM system that we've used in all of the preceding data. So our X field should be easting. Our Y field should be northing. And then we want to set our coordinate system to be WGS 1984 UTM zone 18 north. 16 north, pardon me. So we're going to go in to our coordinate system tab here, projected, UTM, WGS 1984, Northern Hemisphere, and then simply find 16 north. Go ahead and hit OK, and go ahead and hit OK. So you should have what now appears to be roughly the outline of Indiana. You can tell that there's a lot of water sampling stations in the sort of corner of Lake Michigan up here, but there's also sort of following rivers. This is the St. Joseph River right here, and a few others sort of surrounding other rivers throughout Indiana. So at this point we have something that's temporary again. So when it comes up and says water sites events, well, that just means it's a temporary file. So we do want to go ahead and save this permanently. So just choose water sites events, go to data, export data. And if your folder came up correctly, I'm going to go ahead and put this in as water sites spatial. Now if you try to give it the same name, just water sites, it's not going to work because there has to be a DBF associated, so a database file associated with the shapefile as well. So it's going to give you an error if you don't change the name somehow. That's why I just append spatial on here. So go ahead and add it in. You can see that nothing has changed other than the color. And at this point we no longer need our temporary events layer, and in fact we no longer need our original water sites table here. So go ahead and remove that. So you should have water site spatial and water measurements. Now the next step we want to do is create a relationship between these. So we want to create our one-to-many relationship. We want to create our relate between them. And we do this very similarly to how we did the join. So we're going to go to water site spatial, we're going to choose join and relates, go down and choose relate. It's going to ask you first to choose the field in this layer that the relate will be based on. It's station. The other table is water measurements. If you'd left water sites in there, that might show up, but just make sure that you're looking at water measurements. And it's already a sort of auto-populated station here. You could give it a name if you had multiple ones in here, but I think relate 1 is okay in this case. So go ahead and hit OK. And when you open up the attribute table for water sites managed or water site spatial, what you'll notice is that absolutely nothing has changed. It can't append records into the shapefile, into the attribute table for the shapefile, because there's multiple records for each one of those locations. So what it's done instead is it's created this relate, and it sort of happens behind the scenes until I do something. So if I choose just a couple of these things here, just selecting them, once I click related tables and send it to water measurements, it's going to select all of the records in water measurements that are from those sampling locations. So you can see that there were a couple of measurements in 1979, but that's really about it for those particular sites. Now I can go back and forth however I want here. So in this case I'm sitting in my water measurements attribute table. It's sort of bounced me over there, and I'm only looking at the 6 records that are selected. So if I choose over here to look at all of them, and I want to do a select by attributes, I want to just find those sites where a particular measurement has been done. So I'm going to look at what parameter, what measurement was done. And I'm going to use get unique values because there's only, I think, 4 of them in here. So I'm going to look at all of the sites where I have a dissolved oxygen measurement. So there's 3,358 sites that have a dissolved oxygen measurement. So I'm in my water measurements. I've done a selection here. Now if I go and do my relate back to water site spatial, It's going to take it just a second because it's going through and finding each one of those stations and selecting it. So there's 1,055 out of the 1,900 or so sites. And if I close down the attribute table, you can see that these are all of the sites that have a water measurement, or a dissolved oxygen measurement from that particular database. So I encourage you to go ahead and experiment with querying back and forth on these relates. So maybe select all the sites that have a measurement from 1980 or from after 1980 and see which ones pop up that way. So the next thing that we want to do is we've seen a couple of different examples of how we would use the relate to sort of see things on the fly. But there is an interesting thing that we can do kind of working back and forth on summarizing fields to give ourselves a little bit more information about the data. The first of these is working with the water sites here. So we're going to do one quickly here, and then we're going to go back and just do a more brief one on the soil data as well. So if you have the water measurements table up and open, you'll notice that you have lots and lots of different things in here. You have different measurements and you have different years. So it would be useful if we wanted to symbolize, say, the water sites from 1979 for a particular measurement. We could do that pretty easily. So if we clear everything out, the first thing we want to do is create a summary table. And we're going to do this by selecting a particular parameter in here. So let's go ahead and just reselect dissolved oxygen. So what we're going to end up with is an average value for dissolved oxygen. So go ahead and hit apply. It'll give you all the dissolved oxygen measurements again. Now what we want to do is create a summary table that for each station gives us the average value of dissolved oxygen. So I'm going to do that in here by going to, I'm going to do that right here. I'm going to click on station and I'm going to go to summarize. Now why am I clicking on station? Well, that's what I want to summarize based on. For each station number, I want to take all of the values and give the average of them. So I don't need to choose parameter because I've already selected just dissolved oxygen, and it's only going to work off of the selected records. But what I do want to do is go into value. I want to get the average value, and it's probably good to get the minimum and maximum as well. So it's going to go ahead and start to send this to an output table. So let's go ahead and put it someplace permanent. I'm just going to send it over to my data demo 7 folder, and I'm going to call it DO by site. If it gives you an error like this, there's one quick thing to notice in here, and that's that it's trying to save it as a type file and personal geodatabase tables. And what we actually want to save it as a DBase table here. So choose DBase table. Hit OK. It's going to run all the math behind the scenes, create this summary. We do want to add it in. I'm just going to close down a bunch of windows here. Now when I open this up, for each station, I have the number of dissolved oxygen measurements that were there. I have the minimum value, the maximum value, and the average value. Now a lot of them only have one, but other ones we're getting different measurements here. So some of them have 10, some of them have 8. So what's kind of neat that I could do here is I could actually go, and now what I have is something that has a one-to-one relationship. For every station I have only one record, and that one record is in this new table that I've made. So now I could go through, set up a join based on station, not going to water measurements, but going to DO by site. So now when I open my water site spatial, you'll see that for every station that has a dissolved oxygen measurement, I'm now seeing that in there. I'm seeing how many were done at that station, the minimum value, and the maximum value. So now it would be relatively easy to go in and create, for the average value, sort of colored based on how high that dissolved oxygen reading is. So it's taken out all the ones with a null, and it's showing me just the ones, it's showing me an idea of how high the dissolved oxygen, the maximum value, the average value for that particular location is. Okay, so I encourage you to play around a little bit with this, maybe try it with a different measurement. Maybe try looking at it in a slightly different way, maybe for a particular year or something like that. Now the last one I want to show you is just going back to our soil descriptions, our soil Notre Dame with descriptions. So just add that back in. You don't need to create a new file at this point. I am going to just right-click and zoom on it because there's quite a lot of these water sites that are well outside of the realm of where this particular layer is. But I just want to show another example of when you might want to create one of these summary tables. And in this case, we have the area of each polygon here, but we don't have the area, the total area for each type of soil. So it would be really easy for us to, for each soil code, create the total area. We can do that by right-clicking on soil code, choosing summarize, and then for area, we're going to get the average, and let's go ahead and get the sum as well. So it's sending it to the right location. I'm going to call this soil code by area. Soil code areas or something like that. So now this has been added in. When I open it, for every soil code, it's telling me how many different polygons, how many different features there were, what the average area is, and what the total area is. So this tells us something different about the soils. So we know how many different occurrences they are, if they tend to be relatively small, if they tend to be relatively large. So it's a good indicator of something else about the soil data created from one of these summary tables. Now in this case, this isn't one where we would want to necessarily join this back on to the main data because we've sort of taken out a lot of the spatial information there. So that's really about it for tables and databases. I encourage you to experiment around with these a little bit, maybe try them on the sample data that you created in the preceding demos. Feel free to email me or ask any questions through whatever source you've been given for getting more information. So thank you and have a good day.